Hello and welcome to a walkthrough with one of these Desmos lessons. This one is introducing something called lines, transversals, and angles. And we're going to kind of learn what this word transverse or transversal kind of means. So I'm going to start this activity and walk my way through so that you guys can walk yourselves through along with me. So the first thing is stated here. It says the red lines are parallel. So red and red are parallel. Parallel means that they're kind of alongside each other. They're not intersecting. It's not like they're going to pinch closer on one side or the other. They just forever and ever go in the same direction. The red lines are cut by or intersecting this blue line, which is called a transversal because it's transversing or cutting across these two red lines. One of these angles is labeled A, so here's A right there. Drag the black point to show an angle that you think is congruent to angle A. So that one looks like it's congruent. I wonder, I don't know if these other angles down here, if any of them are congruent. But this one right here for sure I think is congruent. Let's see what else we can do with this information. Here are all of your classmates' responses. Now, as other students add to this picture, you're going to see dots across all of them. And for now, I'm going to say yes because mine is the only submission so far. It is congruent because of vertical angles. And vertical angles are when you have two angles across from each other at an intersection. These red lines are also parallel. Drag the black points to show all the angles that are congruent to A. All right, let's see how many we're going to drag here. So we got that first one. That totally looks congruent. Now I'm going to drag some more. It looks like we have 3, 4. We could drag even more maybe. But I think it's just these because I noticed that one of these angles is acute or between 0 and 90 degrees and the other one is obtuse, meaning it's bigger than 90 but not quite 180. So this one here kind of matches A and its vertical partner in that they're both obtuse. And if you kind of look at it, I look at this one here and I notice that it's kind of in the same position, like top left, bottom right, top left, bottom right. So that I think that same position is helping show like that all these kind of have the same relationship here as well. Challenge number 3, do the same thing with angle B. So it looks like now we're looking at all the small angles. So I'm going to drag and make these small angle pairs. So B and its vertical pair, and then its copies over here. These are just copies of the other ones on the left. And here's your work from your previous 2 screens. Single arcs represent angles that are congruent to angle A. So A has these single arcs, and B has the double arcs. Describe 2 to 3 things you notice about how the angles relate to each other. Well, I can see that each A and B have 3 more equal angles. In other words, it's like 2 groups of 4 angles each. So it's like there's 4 B's, 1, 2, 3, 4. And there's 4 A's, 1, 2, 3, 4. I also notice that A and B put together are a linear pair. 2 angles make a line. So A plus B equals 180. And that's kind of interesting because like this, I could go, this way on the blue line, and I have an A and a B making a straight line, so that's going to add up to 180. And I can go this way on the red line, and so A and B are also making a straight line with 180. Cool, very cool. On the upcoming screens, you'll see a new pair of parallel red lines and a new transversal. You'll learn the names of commonly used for various types of angles and consider whether they are always, sometimes, or never congruent. Ooh, let's see what happens. The green arcs show a pair of vertical angles. Drag the two black points to show another pair. Okay, I'm gonna do these two big ones across from each other. And our vertical angles always, sometimes, or never congruent. They are always congruent because this is a relationship that we explored already. But it has to do with adding up to 180 in different ways. Continuing on here, we have linear pairs of angles. In other words, two angles, kind of like a small one and a big one, that make a line. So drag the two black points to show another linear pair. I'm going to go down here again. This time I'm going to do these two. And when I put them next to each other in that way, notice that it's like one continuous arc that makes a straight line, or a straight angle, which makes 180, and that's a linear pair. Okay, so linear pair could have been that. I could have put it here. I could have put these two. I could have done a pair from up on top, but it just needs to be a pair of angles that makes a straight angle. These are usually not congruent, but maybe sometimes, because if it was split half and half, like 90 plus 90 equals 180, then they would also be equal. So that's kind of interesting. It's like it's not congruent unless it would be like a half and half split where one angle was 90 and the other one was 90, because otherwise you're going to have a little one and a big one like that. Okay, let's share with class. Move on to the next one. Same side interior angles. Okay, so the green ones are being called same side interior. And the way that we interpret this, when we say same side, I'm looking at this blue line, and both of the green angles are on the left of the blue line. And then it has another word, interior. And interior means it's in between the two red lines. So where else do I have another relationship where I have two angles on the same side of the blue line? So now I'm putting them on the right. And this could be same side, but they're not interior because one's outside of the red lines and one is inside. Or like here, one's outside and the other one's outside. So same side interior is going to be right there, those two angles, kind of like the green ones. The two green ones, I don't think they're going to be ever congruent, because when I look at them, I have a big one and a small one. But you know what? Maybe these can also split half and half, where they both equal 90, that's kind of interesting. Let's see how this plays out even more. Now we have something that says alternate interior angles. Okay, so interior means inside the red. That one's inside the red. That one's inside the red. Here's another one that's inside the red, but alternate means that we have like these two angles here. And if you look at them carefully, they're on alternate sides of the blue line. So alternate sides of the blue line, and they're both inside the red lines, means that we have alternate, both sides of the blue line, interior angles, interior meaning in between. And these look the same because like the green are both big and the black are both small. I'm going to say always congruent because they both look the same size. And notice this. If I were to like drag this one and just pull it down here, it looks like it'd be the same thing. Like it would never change size. Like it was up there and then I can copy it down here. And if you drag a vertical angle from the top to the bottom intersection, from the top intersection to the bottom intersection, then you have alternate interior angles. Cool. All right, we're almost here toward the end. The green arcs show a pair of same side interior or exterior, same side exterior. So both on the left and both outside the red. So now I'm going to do the other side, both on the right and one outside and the other one also outside the red. So both on the right side of the blue and outside. And when I look at this, I see a big one and I see a little one. I'm going to say sometimes congruent. So maybe they both equal 90 in some cases. But most cases you will get a big obtuse angle and a little acute angle. Awesome. All right, alternate exterior. This is our last set, so we got to do outside exterior. I'll just pick that one there. Now for it to be alternate, it's got to be on the left side. So not there because that's vertical, but it's also inside it. That's interior. This is also interior. Finally, I get down here and it's exterior. These look the same. These look the same. Again, it's like a copy of a vertical angle. Awesome. Corresponding angles. Ooh, I see this and I see two angles that look like they're in the same position and the same measure. Like I got one in the top left, one in the top left. So if I wanted to do one in the bottom left, I could do another one in the bottom left. Or I could do one in the bottom right and one in the bottom right. And when I say bottom left or bottom right, what I'm looking at is each of these intersections, like top left, top right, bottom left. So these corresponding means that they got like the same location at each of their intersections. So those look always congruent because they are copies of each other. Awesome. Write 2 to 3 sentences describing your biggest takeaways from this activity. Use as much academic language as you can. So I noticed that some angles are copies or are congruent of each other. I also noticed that sometimes the pair of angles are one big and one small. And I'm going to put some other words here to use like the academic language. Obtuse and one small, acute. It wasn't always like the inside or the outside or all those different kinds of things. Like sometimes they matched and sometimes they didn't. There are also angles that add up to 180, like a linear pair. I saw that a few times too. Awesome. And then final screen, what happens if the red lines aren't parallel? So I can move these red lines around if I need to. And so I'm going to do this like that. And which angles are still congruent? Ooh, so this is kind of interesting. Like this big angle here in the top right and this big angle here don't look quite the same. Like the bottom one looks a little bit bigger. Same thing with like this little angle and that little angle do not seem the same as these two little angles up here. Like they don't quite fit. But a vertical angle is always going to be congruent because those are across from each other. We've already seen that relationship. These two angles across from each other at an intersection are going to be equal. The rest of them, I don't think any. I think vertical is the only one. So that's it for kind of this little bit of exploration with lines, transversals, and angles. And we will get more into exploring this relationship and practicing these relationships throughout the next couple weeks, actually. And that's it for this video. Thank you.